Okay guys, so I'm here stressing like hell, trying to work out solar intensity in northern Pakistan, where leopard geckos live in the wild, and I'm trying to kind of replicate that area. And with science and maths and technology, you would think that we could be able to do this, but with a brain like mine, that is not the best when it comes to physics and maths and engineering science. It takes a long time and it causes a lot of headaches, and I don't know why I get myself into these situations. I think it's just because I am a bit of a perfectionist and it gets in the way, and then once I start something I just can't stop. So here I am with a blank page virtually. Light intensity, and I figured out northern Pakistan is on 75-degree east latitude on the Earth's sphere, and 35-degree longitude, and I got that information from this graph here, which I got from Wikipedia. So let's have a look. If I just go back a couple of pages. Solar Irradiance. Okay. This is like major physics now, guys. And I've not really, until now, until keeping this reptile and trying to get things, to mimic nature as much as possible. I mean, it's not going to be perfect. I've got to kind of accept that. But when you have, I don't know, I get myself into these kind of muddles. But yeah, there's a lot of kind of like physics and maths and stuff involved here, and yeah, trying to get my head around it all. Look, there's even mathematical equations, and I'm like, oh. Right, so how can we what can we draw from this? So I have a heat lamp in the terrarium at the moment, which is a 75-watt tungsten halogen, and that is controlled by a thermostat, which is set to a certain temperature to stop the terrarium from overheating. But that doesn't mean to say that the terrarium is set at that temperature all the time. So that it doesn't mean the temperature in the terrarium is like what it's set to on the thermostat. I've got some weather data from, which I've already shown you in a previous video. So this is a place in northern Pakistan near the Potwar Plateau and Salt Hill Ranges, just to try and kind of mimic it really in the terrarium. So this is like in the wild. This is in nature in a place in Pakistan called Nali. But now what I'm trying to, so I've basically got this sorted. I use digital timers so that the lighting, the hours of light, to get that day and night cycle figured. So, but now what I'm trying to do is look even deeper. I'm trying to measure, or trying to work out how to measure, or the wavelengths. But I think I'm going too deep here, and this is why I'm getting stressed, because I'm just like, what the hell? So yeah, if we go back to this map that I was looking at, so I got it from this page here on Wikipedia, so we can see it there, and I'm just going to go into the bigger version of it. Okay, so this basically is a map which shows the direct sunlight irradiation across the world. Now, so just for comparison, so where I am in the UK, we live in kind of like a temperate climate because we're surrounded by the big blue sea. Basically, we're an island, and then we have continental Europe here, and the jet stream obviously coming up here, which kind of affects our climate. And then if we go to like Australia, look how it's all kind of like red and orange. So there's stronger sunlight there. So your bearded dragons live in Australia in the wild, and that is why, so the stronger irradiance of sunlight here basically explains why bearded dragons need stronger UVB provision and stronger heat generally, because they live in kind of like arid terrain in Australia. Whereas your leopard geckos are kind of like, so if I zoom, leopard geckos are in Pakistan, which is this sort of area here, Iran, which is this country here, Afghanistan, Western India, and Nepal. So this area is, if we look at the sort of the border of Pakistan and Afghanistan and Iran, it kind of is similar. The colour is similar to that in east coast of Australia. But if we go into like the northern area of Pakistan, which is where I'm kind of focusing on in terms of replicating habitat, we can see that there's a little bit more green, so it's a little bit more temperate. And then if we look at the numbers, so daily total. So this is just like averages, long-term average of direct sunlight, measured in kilowatts per hour per meter squared. Now this device, the RSM 400, is a solar irradiance meter. This reading I took from outside about 20 minutes ago or so. So outside in direct sun, bearing in mind that there is cloud cover today and it is in sort of heading towards late September. So that was the reading, 363.3 wavelengths per meter squared. But that's in Denbighshire, North Wales. So it's, it's not going to be the same as in Pakistan. But if we look at the colours on the map, so this is where I am in North Wales, and then this is Pakistan. So obviously North Wales there's going to be less intense sun because it's more north on the earth, and temperate climate because of the big blue sea. So this part of Pakistan is kind of similar colours to northern France, really. And northern Europe. So anyway, what I'm struggling with at the moment is trying to interpret from the solar intensity in Pakistan, which I would say is probably around this central area here. Say 3.5 daily total and about 1,270 yearly total. So that's kilowatts per hour per meter squared. Now, this meter, so if I was to measure the irradiance in the terrarium now with this under the halogen, it comes up to something like crazy, like 900 watts per meter squared. So I think that is rather strong. But then one could argue that the Gecko doesn't come out in the day, and he never goes out onto that ledge in the during the day because of heat. And because of its proximity to the slate ledge, and that the slate convects heat, that may give the stronger reading. And the lizard is perfectly healthy. I mean, last night he literally leaped from that top ledge onto this kind of stick thing here to grab a locust, and he literally jumped, grabbed the locust, face planted the locust, had it in his gob, fell to the grass, and then ran off. So, I mean, he's a tough little guy, and, you know, would he be so active if the temperatures in there were so, you know, different or whatever? I don't know. I mean, obviously they're going to start getting cooler now because of the seasons changing, which they are doing. But yeah. So the wavelengths, the watts per meter squared reading I had was about 900, 930. Yeah. So, you know, that's just my honest, accurate kind of reading of that. Yeah. So what I'm trying to interpret is, obviously that is well different to the sun in Pakistan. So 900 in a day, 900 watts per meter squared. So then if we, with this being kilowatts, do I need to multiply that 900 figure by 1,000, which would like take it to 900,000? I think that this is where I'm having difficulties interpreting the power of the heat source and comparing it with the power of the sun's irradiation in the wild using this information. So using that kind of in between, so say 1,277 kilowatts per hour. So I don't know if there's anyone out there that can help me out with this, because I'm really struggling. And I'm thinking, do I need to get a less powerful bulb? Probably yes. But then if the lizard is so active and healthy, then do I really need to? And, you know, the temperature in the terrarium now, the climate is kind of closely replicating the climate in this region that I've got here. So there's kind of lots of different kind of arguments to kind of, do I change the light bulb or do I keep it? And how do I interpret that information and compare it to the light bulb? So that's where I'm at, guys. I'm kind of at a bit of a bit stuck, basically. Everything's all fine at the moment, but it's just trying to work this out, and I'm just like, whoa. So yeah, if you can help me out, guys, if there's anyone out there that has any information to help with this or work out these equations, then do comment below. But yeah, it's not an easy one to kind of explain, really. So yeah, let's try and fill this blank page with just a title with some evidence, because I mean, it'd be great to know how. I mean, it's just my brain not being able to understand the concept and the mathematical element. That's what I need to figure out. How do I mean, I know how to convert kilowatts per square meter to watts per square meter, because it's literally kilo means 1,000. And so like this here, so this is 363.3 watts per square meter. That's like the sunlight taken from outside this morning in the garden. So that in kilowatts per square meter would be 363 times 1,000. Yeah? Which would get the kilowatts reading. But then when you look at this chart, it's totally different again. So this is where I'm getting confused. So yeah. That is all for now, guys. Thank you very much.